Okay, we're going to do a two-sided hypothesis test for a proportion in this video. And I've been doing a lot of videos on hypothesis tests. There's a lot of different types, one-sided to the left, one-sided to the right, two-sided. For the means, remember, we had to determine whether we were using a z-test statistic or a t-test statistic. And with proportions, very nicely, it is always a z-test statistic, which makes our work a little bit less complicated or involved. And this is an example of a two-sided hypothesis test for a proportion. And again, here's the situation. We're going to have an infinite number of different kinds of situations. All we're concerned with is the numbers, the values that allow us to perform the test and to answer the question that's being asked by the test. So here we have a situation according to FBI statistics. 70% of all arrests are of males aged 15 to 34 years old. A sociologist takes a sample of 32 in a certain town that he lives in, and it shows that 24 of them were males aged 15 to 34. And we want to use a 5% significance level to test the claim that the population proportion of such arrests is different. So that word different is the clue that this is a two-sided test. It doesn't say we want to show that it's more than 0.7. It doesn't say that we want to show that it's less than 0.7. It just says that we want to check to see if it's different from 0.7. So that tells us it's a two-sided alternative. And that's going to affect our p-value calculations, just like in any other two-sided test. But the four steps are still the same. So the null hypothesis, we're going in with the idea that 70% of all arrests. Kitty, what are you doing? Come here. Little Kitty wants to make an appearance on the video. She's mad that she doesn't get any camera time. So here she is. This is the queen. Now go play. All right, where were we? Null hypothesis is that the unknown population proportion is 0.7. Whereas the alternative is that it's different than 0.7. Okay, different, not equal to. Not a greater than sign, not a less than sign, but a not equal to the hypothesized value of 0.7. It's a two-sided test, and we are told to use an alpha level of 5% or 0.05. So again, first step, it's all notation. Make sure you get that right, please. Second step, always a z-test statistic. Hopefully at this point we know the form of our z-test statistic. The numerator is just the difference between our sample proportion, right? We had to get our sample proportion. 24 out of 32 was the sample proportion. 32 is the sample size. So there's our sample proportion, and the difference between our sample proportion and what we think going into the test divided by this expression here in the denominator. Again, remember, be careful, use the p sub 0 here and here, as opposed to the confidence intervals where we used p hat here and here. So very important difference. Confidence intervals, we use p hat here and here when we're looking at the standard error of the sampling distribution of p hat. For hypothesis tests, we're going to use the hypothesized value in our expression here in the denominator of the z-test statistic. So we throw all those numbers in, we calculate the z-test statistic, sample proportion minus hypothesized value, 1 minus hypothesized value, sample size, square root of that whole thing, round to 2 decimals. As always, we round to 2 decimals because that's the way the table is set up. Again, please use the numbers in the table, not your calculator, to come up with these probabilities. That's why on the last test, some people had a point taken off because their answers were very close to the correct answer because they used the calculator, but I specifically asked you to use the tables and the z-values, and that's why you got a point taken off. Anyway, our z-value here, rounded to 2 decimals, is 0.62. So looking at this, our value of 0.75 is not even 1 standard deviation above the mean of the sampling distribution of the sample proportion if this was true. So when we go to find a p-value, we don't expect to get a small number. We expect to get a pretty large number because this is not very far away from the center. So the probability of getting a value like this, given that this is true, isn't going to be very surprising. And in fact, when we do that, when we calculate that p-value, and this is where the different or two-sided alternative comes into play. When you're finding the p-value for a two-sided test, you are doubling the probability of finding something more extreme than what you found in your evidence step, your step 2. This is a positive z-value. So more extreme than that would be even further to the right of center of the standard normal distribution. So twice the probability of finding something more extreme further to the right than 0.62. If this was negative 0.62, then we would be looking for z's further to the left of that negative number. So more extreme is what we're looking for. If it's positive, we're looking to the right. If this was negative, then we would be looking to the left. Either way, we're doubling that probability because it's a two-sided alternative, and we're looking at both ends of the curve. So we look up this number, we find this number. In our z-table, again, 2 choices. You can use complement method. This probability here, the probability that z is greater than this number, is 1 minus the probability that it's less than that number. Or you can use the symmetry method, which I used here. The probability that z is greater than any z value is the same as the probability that z is less than the negative of that z value. So we look up this value in the table, negative 0.62. You're going to find this value in the z-tables. You double that value, and we get a huge p-value. Right? This is a huge p-value. And again, remember what we're saying. We're saying that if our null hypothesis is true, we expect to see something this far away from that, well, over half the time, 55% of the time. So it's not surprising at all. So that leads us to our conclusion that since the p-value is greater than alpha, and in this case, much greater than alpha, we do not reject the null hypothesis. We do not have enough evidence to suggest anything other than what we thought going in. So we do not have evidence to go to the alternative. We are staying with the null hypothesis. Again, 4 steps, always the same 4 steps. The only thing that changed in this example was that it was a two-sided alternative because it said different. So it was a two-sided alternative, and we double the probability of finding something more extreme than we find in our step 2 test statistic calculations. All right, so that's another example of a hypothesis test, and we will continue on.